Hello guys, and welcome to another video. Today we're going to be solving problem 31 on Euler, which is the coin sums. In England, the currency is made of pounds and pence, and there are 8 coins in general circulation. It is possible to make 2 pounds in the following way. How many different ways can 2 pounds be made using any number of coins? So this is a DP problem, a dynamic programming problem, and if you've taken any algorithms course in college, I did this 3 semesters ago, so I have seen this problem before. Typically, you will find this in the book, right? Also, if you don't find this one, you typically find the subset sum problem, where you're given an array and you have to use subsets of that array to find numbers that equal a certain number that they give you, right? Also, you can use knapsack, which is a greedy algorithm, to figure out what's the optimal change for this problem. So what I'm going to do is provide you guys with the iterative and the recursive solutions for this. However, it takes a while for anyone to wrap their heads around dynamic programming. It looks really simple on the surface, but it's a lot harder than most people think. So what we're doing with this problem is pretty much we're looking for nominations, right? So we're looking for the different ways that we can actually give back change. And typically with this problem, what would happen is that sometimes you would have the same nominations, right, for different subsets of coins. However, we're not going to be taking care of that in this one. We're just going to be writing the code to solve the problem for your order. All right, so let's get started. So open up your favorite IDE. I'm going to be using Visual Studio Code and create a new Java class. I don't want this in here. Let's create it outside. There we go. Call this one coin change. Call it whatever you want. Doesn't really matter. I can do just declare the class. All right. So what we need first is to create a method. So I'm going to first provide the iterative solution first, and there are problems with this one. The problem is that sometimes you do have an overflow when you use primitive types, so I'm going to convert that to data types by using big integer instead. All right, but first what we need to do is keep the interface with the recursive part the same as that of the iterative part, so I have to add some few methods to get the right answer. So what we need to do first is return an array of all the coins that we want from an array to big integer array. That's it. And we can use streams to map our primitive array to an object array. So it's going to be static, and we need to return a big integer array. And then we call this one DP coins. This is going to take in the coins. We can just go ahead and return, use the arrays, and then use stream, and we can take in the coins here. And next what we want to do is we want to map to object, right? And what we're going to do big integer. For now, sometimes this like helps me, and then other times it's like doesn't want to do anything. Use the value of, and then dot, and I could just add that. Let me bring this down here, and I'm going to use to array, and then I want to create a big integer array object. Yeah, and that's it for this part. Alright, next what I want to do is create a method to initialize the array that we're going to be using to keep track of the answer. And I'm just going to call this one initialize DP. And this is going to go ahead and take the big integer array that we need to go ahead and initialize. And just call this one coins, and then the cache. So here we can create a final variable. I'm gonna call this one size. It's gonna equal to cash plus 1. You can create a for loop. Index is less than the size. Index plus plus. And you say coins index. It's going to be equal to, so just we're going to initialize them to big integer dot 0. So just put them all to zeros. All right, and this is it. Now what we want to do is pretty much go ahead and create the change algorithm. So it's going to be, make this all private, static, big integer. And let me just make sure that, okay, so it's importing right. And this is going to be the iterative solution. All right, and so what we need to do is take in the coins and the cash. Like I said, I want to keep the interface for both the recursive and the iterative like this. So we just pass in coin and cash. So first we want to go through some basic steps, some base steps. So if cash is equal to 0, right? So what happens is that if we have 0 cash, then we're gonna give 0 coins. So, and 0 coins means that there is an empty set of coins that we're gonna use, right? So because it's an empty set, that counts as part of the total set. And so instead of returning 0 here, we're gonna return big integer .1, because a no set counts as one set, right? Probably just typing it in probably faster. All right, so here we have no coins used. All right, so what happens if we don't have cash but we have coins? So no cash but coins available. Then we can't really give in any change. So if cash is less than 0, then you can just return big integer .0. Next, we're gonna check what if we have cash but no coin. So if cash is greater than 0 and coins dot length is less than or equal to 0, then we can't really give back any change. So here we're going to return big integer .0. Right, so here cash available but not coins. All right, so now that we have this, we can now start taking care of other stuff. So the first thing is we need to keep track of the array that we're gonna use to find the solution. It's gonna equal to new big integer, and this is going to be an array. This is going to be the cash plus 1. The reason is because we want to return the spot where the cash is at. So if we don't add plus 1, we're going to be 1 less than the cash, right? So next what we want to do is we need to go ahead and initialize this. So this is going to take in dp here, right, and cash. All right, what is giving me an error? Sometimes it does this. I don't know why. So let's see, DP. Okay, that's strange. We're gonna keep going and see if something happens. Oh, so it changed now. All right, so what we need to do next is we need to go ahead and get the DP coins that we get DP, I guess the lowercase. This is going to equal to DP coins, and then we're just going to pass in the coins here. All right, and then I'm going to put spaces in here, makes it look cleaner. All right, and then what we need to do first is we need to keep track of the size. So we're going to create final variable size. It's going to equal to new big integer, and I'm going to use long dot toString here, and I'm going to pass in dp dot length. All right. So finally, what we want to do is we want to set dp dot 0 to equal big integer dot 1. All right, that's because the empty set has one solution. All right, so that's why we're putting this to 1. All right, so now that is done, we can go ahead and start coding the solution. So we're going to say for var coin in dp coin, right? Then we're going to need to create another internal for loop. We're going to just var x equals to coin x dot compare to size is less than 0. And do x dot add big integer dot 1. All right, so to make this stack, we're gonna add plus here. All right, so what we need to do is we're gonna say dp, right, and then what we're gonna do is we're gonna use x dot in value equals dp dot with the subscript x dot in value dot add dp subscript, and this time we want to get x dot subtract, and we're going to subtract coin, and then we want to go ahead and get the int value for that, and that's pretty much it. Lastly, we can go ahead here and just return dp and cache. Okay, so hopefully this works and there are no errors. Now let's just go ahead and test this before we continue to the other part. So what we need is the coins. It's going to equal to new int array, and we can just type in the coins manually. 5, 10, 20. I think next one's 50, 100, and 200. That should give us 8. That's good. And then we need the cache. It's going to equal to 200 pens. Then we need ways. It's going to equal to let's see, iterative solution. And then what I want to do is just leave this as not this part right here, but there we go. and then we can just print our ways. So the system dot out dot print line and ways, and that's it. Now let's go ahead and run this. You can just go ahead and click here, and that should give us the solution. So this is the right solution for this problem. Now what we're going to do is build this problem iteratively. Recursively. Okay, let's do that. This is going to be a private static int, and I'm going to call this one recursive solution. And what we need here is we need the coins, and let me just close this here. We need the coins, and then we need the number of coins, and we need the cash. I'm just gonna type here. All right, so that's it. So all the base cases here apply, so I'm just gonna go ahead and copy this here, and we need this here. In fact, if you don't have this here, most likely this algorithm is not going to work, because for all these cases it needs a spot to exit if one of these cases is actually true. So here we return 0, we return 1, and then we return 0 here. And that's it, and we're done with this. All right, so you already know how these cases work. Now this is the magic. All right, so now here we return a recursive solution. We're gonna take out coins -1, right, plus, and then a recursive solution. And what we want to do here is take the cash, right, want to minus the coins with the subscript n coins -1, and we need to return here. And this is it, and this is it pretty much. Like I said, I'm going to provide you guys with the solutions, and you're going to take your time to write the nominations down and then figure out how these recursive solutions work, because I can draw you guys a whole entire graph and you might not still get it. It's better if you do it by yourself. All right. There are a lot of resources on YouTube that will at least show you guys how this works. It might not be the same code for this, but it will be close to this one. And for this one, I remember a couple of semesters ago, I did watch the one for HackerRank, and that was confusing in itself. I didn't know why they had to keep a key and map the indexes that were found, because for some reason it just felt like boilerplate code to me, and I didn't see the reason exactly why we had to add that. Maybe there was a reason, I don't know. But okay, so this is it for the solution. So what we can do is we can just pretty much let's comment this out. Let's just let's comment this out and create a new variable here. So other ways is going to equal to. And before we do this, you can see that we have 3 arguments here, and it doesn't match the arguments that I had up here. So obviously this will still work if we just pass in the length here. But what we can do is create some wrapper class that takes care of wrapping the code for us. So we're going to do a recursive solution wrapper. And this is just going to take in the coins and the cash. Sorry for that. And now we can just go ahead and return. And then for here, just change this to coins.length. And now we have some wrapper with the same signature. And let's not forget to add the return statement. Alright, so now we can go ahead and just do a recursive wrapper, and then that would then match the signature that we had earlier. And we can then rerun this again. And I guess I could do, yeah, let's just run this here. And if you go over here, let me pull this up. Sees that I am getting an error. Okay, so I guess I have some things I need to fix. Alright guys, so over here, at least here, what we need to do is, instead of saying that coins.length is less than or equal to 0, change this to endcoins. Endcoins. The reason why we have endcoins here is because we don't since we're shrinking the array, right? Since we're shrinking the array, if we use coins.length, right, then it can't really keep track of the size appropriately. So if we wanted to work with something, we probably have to use system.arrayCopy as we are going around and shrinking and using it again. So that might be a little bit more difficult to write. So instead of doing that, we just keep track of the length, right, and then we can use that to actually just shrink the array that way. And now if you go ahead and build it one more time, so let's go down. So this is still the recursive solution. I haven't changed it, and run it. You should get the same solution as the one earlier, and there we go. So guys, this will be it for this tutorial. Hopefully you guys liked it. If you guys have any questions that you guys want to ask me about this problem, or you guys want me to do some type of visual representation on how it works, I can take the time to show it. Probably right after I take my physics test. I'll have some free time. Alright guys, this will be it. I'll see you guys in the next tutorial. Have a good day. Bye bye.